All right, so next let's talk about step functions. Okay, and so let's start by taking a look at this example, okay? So you can see, you may have not seen anything like this before, right? Like there's a whole bunch of things going on here. You got kind of that set of, y is 1, y is also 2, y is also 3, and y is 4. And then you can see that there's some domain restrictions listed off to the right for each, okay? This is what we call a step function, okay? And so what you can see is we have a series of 4 constants, okay? That's going to produce little line segments, horizontal line segments, that is, at each of the domain restrictions that you see off to the right. So the first line segment is going to be y equals 1, the top one, okay? And it's going to be 1 only from 0 to 1, okay, where it actually touches 0, so shaded in on 0, but there's no equal sign with 1, so it's going to be an open dot, okay, at 1. And so this graph is going to look something like this, okay? So it's 1, okay, the horizontal line, y equals 1, but only from 0 to 1, okay? And then it goes up to 2, and it's 2 only from 1 to 2, okay? Inclusive of 1, but not inclusive of the 2, and so on and so forth. And we call this a step function because it looks like a series of steps, okay? And so it's a step function. Another name for a step function is called the greatest integer function, because for every real number x, you want to take the greatest integer less than or equal to whatever x is, okay? And so if we take a look, for example, this is kind of like the parent y equals bracket x, close bracket. This is what kind of the parent step function looks like, okay? So it's 0 from 0 to 1, it's 1 from the domain where x is 1 to 2, and so on and so forth. Okay, so let's take a look at the we problem. We're going to write and graph a piecewise function for these parking rates that you see over here. So you're going to, park your car at a garage, and you notice that this is the sign right over here, okay? So it's $3 for a half hour, okay? So if you stay for a full hour, that would make $6. But then after that, if you stayed for another half hour, that would be $9, right? But it's saying that, you max out at $8, okay? And so just kind of think about that. That means that your function would look like this, right? It's $3 from 0 to 1/2 of an hour, right, where t represents time. Then from half an hour to an hour exactly, that would bump you up to $6. But then after you surpass 1 hour exactly, okay, up to 12 hours, or apparently they tow your car or something, anything from 1 or more hours, or over 1 hour rather, is just going to be a flat $8. And so if we go ahead and, so there's what our function would look like. And then if we go ahead and graph it, that means that it would look like this, okay? All right, so let's take a look at the we problem, or the UL rather, okay? So what if it's, y equals the greatest integer function, but then plus 1? Okay, so why don't you sub in some values, maybe make a little chart, and when you do, you should hopefully end up with this. All right, so good luck and get to the practice.